which meant we needed a common denominator, and we wanted to reduce rational expressions. Okay? So today we have an equals, which means we have an equation now. And within an equation, we want to solve. So now we are no longer keeping the common denominator. We still have to talk about the common denominator. We are not keeping it. We are trying to get rid of it. So for instance, pulling this out of the air. So something like this, okay? I want to solve this equation, 4x. So the first thing that I want to do then is, let's get rid of the denominator. So that's what I would always do. So you don't need to write this down. This is just a very plain example, all right? So what's the denominator that I need to get rid of? X. And how do I get rid of it? Say it again? Yeah. Thank you. I'm going to multiply, and I can't just multiply one term by x, I have to multiply all of them by x. So my objective here is to get rid of the x. Okay, that's the objective. Get rid of the denominator. Not necessarily the x, but the denominator. So that x and that x, they cancel. Alright, so what am I left with? 4x squared plus 6 equals 2x. Subtract 2x. Then I would have this equals 0, and I don't know if it might even be factorable. What would be the first thing that you would do here? Yeah, what is it?
2.
2. Now because I'm solving, I can divide everything by 2 and leave it out. I don't need it anymore. So that leaves this with 2x squared minus x plus 3 equals 0. All right? Am I following so far? It's factorable. 2x, 1x. I'm going to put the 3 here and 1 here. Now again, I'm doing this in my head because I know what the outcome I want. That's that. Okay, so I just factored it. The only factors of 2x are 2x and x, and the only factors of 3 are 3 and 1. And I need it to be a negative x. So negative 3 times x is negative 3x. 2x times 1 is 2x. So when I subtract them, I get negative x. So then x, therefore, is equal to 3 over 2 and negative 1. Okay? Again, I also have to have this down at the top as well. X can't equal 0 is my restriction. Because if it came out down here as this being 0, it can't be a part of the solution because I already said it can't equal that. Okay, so that's a very basic question. So what you have been doing is you've been working through very complicated expressions, polynomial expressions, trying to reduce them, trying to get common denominators and the whole bit. So what we're going to do then is we're going to take it to the next level and we'll find out what are the values of x that make the left side and the right side equal. Okay, so let's look at that first question. I have x squared plus 25. Over, is it x minus 7?
Yeah.
Yep. Plus x plus 5 over 2. And that is equal to 2x squared. Now, again, I'm going to work through this by factoring. Okay, so my intended goal is to factor. So I'm going to jump a step. I'm not rewriting the whole equation out. I'm going to factor. So I got to factor 2x squared minus, so that's 2x and x. Okay, and I need a minus 9, so that's 18, negative 18. You know what? Why don't I do this over here? Okay, so I want to factor this. What's the middle term?
Negative 12.
Thank you. Negative 12x, add 18? Or add 9, sorry?
Negative 9.
Subtract 9. Okay, so what's my product? Negative 18, right? My sum has to be negative 12, and are there factors of 18 that would give me negative 12? I think so. No? Doesn't look like it, does it? No? Okay, so, oops, I'm going to do this now. And I'll go back to here, and I can't factor this. So I gotta just leave it as it is up here. So 2x squared minus 12x minus 9. So I'm gonna leave that there. Can't be factored. Alright, what about the bottom? Can the bottom be factored? 2x subtract 14, can that be factored, Eli?
You have to look at it.
Look at 2x subtract 14. Tell me if it can be factored.
There's no squared value.
Okay, but does that mean it can't be factored? What's the first thing you always look for in factoring?
Your product.
No. What's the first thing you always look for when it's factoring? Especially a binomial. Is there a factor in there that goes into both 2x and 14?
2.
2. So can I factor a 2 out of there?
Yeah.
Yeah. So there I have it. Alright. So there's everything broken down as far as I could break it down, alright? So, number one thing I need to do is find my restrictions. What can x not equal? Looking at all my denominator, what can x not equal? What is it? 7. Okay, great. We got that so far? Okay, now here's yesterday's work. What is my common denominator here? Yeah, and? Okay, so for those of you that struggled with yesterday, I'm going to show you a simple way of doing this, but it's going to be longer. It's going to take more steps. For those of you that can see that common denominator being 2 times x minus 7, I'll show you how to do that as well. Alright, so I want to get rid of the 2. Let's start with that, okay? So how do I get rid of the 2 on my denominator? Multiply everything by 2, right? So I'm going to times this top part here by 2, times this top part by 2, and times this top part by 2. Okay? So I rewrite the top here, 2x squared plus 50 over x minus 7. Plus, that cancels, and that cancels. So I got rid of my 2's there. So I'm left with x plus 5 here equals to 2x squared minus 12x minus 9 over x minus 7. Alright, so I'm doing this in 2 steps now. What's the next part of the denominator I want to get rid of?
X minus 7.
X minus 7. So I'm going to multiply everything by x minus 7 now. That by x minus 7. That by x minus 7. So I'm going to put that in brackets. And this by x minus 7. Just like that. Okay? So looking at this guy right here. Those cancel. What am I left with right there? Yeah. Let's speak a little louder here. I want everybody involved today. 2x squared plus 50. What do you suppose I have to do right here now? Multiply them, which is, what do I do when I multiply a binomial by a binomial? Foil them. Okay? So can I do the FOIL? Does everybody understand how to do FOIL? So I can do it without having to show every step. So that gives me x squared minus 2x minus 35. Okay? X times x is x squared. 5x subtract 7x is negative 2x. 5 times negative 7 is negative 35. Equals 2. How are we doing so far? Okay? cancel, cancel. So what's left on the right side of this? That. All right. Any questions so far? Seth, are you writing all this down? You should be. Are we okay? Now what do you suppose I do here? Collect like terms and?
Get equals 0.
Yes, nailed it. 2x squared plus x squared is what? 3x squared. Subtract 2x squared leaves me with 1x squared. Let me change the color here. Let me change the color. I don't like the color. I'm going to change it to this. So I got 2x squared, or sorry, 1x squared here, right? Okay. I have a minus 2x here, and I'm going to add the 12x to the other side. So what do you suppose I have? I have a minus 2x here, and I'm going to add the 12x to that side. 10x. Okay, so that's taken care of. I have 50 subtract 35, which is 15, and I'm going to add 9 to that. What does that equal? 24 equals 0. Okay, 2x squared and x squared make 3x squared. Subtract 2x squared is 1x squared. Minus 2x, add 12x, it's 10x. 50 subtract 35 is 15. 15 plus 9 equals 24. Okay? Now you're back to what you did 2 or 3 units ago. First thing you probably want to do is factor. What are the factors of 24 that add to give me 10? 6 and 4. So your solution is that. Okay? Yes, sir.
What would you do the shorter way with like,
I would multiply everything by 2 and x minus 7 in the same step.
okay, so
I'll show you. Let me show you that, okay, so that everybody can understand it. Okay? All right. First step is to get rid of your denominator by multiplying everything by the same thing. Okay? Now you can multiply it all by 2, or each individual denominator if you like, or you can multiply it all by once, which I'll show you in a second here. After I got rid of my denominator, I just collected like terms and let it equal 0. You do that every time. Okay? And then after that, it's the same old for you. Factor, solve, done. Yes, Eli?
You know how you have x can equal 7?
Yes.
Is that because your last one was x subtract 7?
Because it's on the denominator up here, and I can't get a 0 on a denominator, can I? So x minus 7 can't equal 0. So what value of x is going to make this equal to 0? That's 7. That 7 subtract 7 is 0. I have undefined values, I can't have that. That's why. Does that answer your question?
Sort of.
Okay, anytime there's an x on the bottom, on the denominator,
It stays.
you have to find out what it can't equal so that you'll end up with 0.
Okay.
Okay?
Thank you.
Alright, so I'm just going to use the first part of this equation to show what I would have done. I would have gone from this step directly to this step. And to do that, I have x squared plus 25 over, what was it, x minus 7, correct? Okay, so all I would have done, don't write this down, all I would have done is this. Times by 2 times by x minus 7. That's my entire denominator right there. That's the common denominator. So then I would have just done this. That would have canceled. So I would have done that all in one step for all 3 terms. So I would have times this also by x minus 7, this by x minus 7, and that by x minus 7 as well. All in one fell swoop. Alright? Okay, so again, quickly through it, let's show you another question. 5x over x minus 4 is, where do I see that? Plus 2 equals. I already got 3x plus 8 over x minus 4, is that right? Okay. First things first, Eli. You asked the question, what can x not equal? 4. Very good, Eli. You nailed it. Okay. After that, now I want to get rid of my denominator. How do I get rid of my denominator? So what am I going to multiply everything by?
X minus 4.
Everything's going to be multiplied by x minus 4. So this is x minus 4 times this, x minus 4 times this, and x minus 4 times that. Okay, that's it. All right. So now I want to cancel where I can cancel and then write what I have left. So this is going to cancel with that. What do I have left? 5x. Okay. I have to distribute 2 through here. So what do I get? 2x subtract 8, and all of that is equal to, again, cancel that out. What am I left with over here? That's right. Okay. Now what's the last thing I want to do to before I do anything to solve? Collect the like terms. Okay, now, if one of those expressions is a quadratic, is a squared value, then I definitely want to get it equal to 0. But because I only have x's here, I want to get the x's on one side and the numbers on the other. Okay? So this is like a linear equation now because I only have x's. So I have 5x and 2x make what? 7x, and I'm going to subtract the 3x. So what does that leave me with? 4x. Okay? I'm going to take this negative 8. I'm going to add it to that side. What's 8 plus 8? 16. Okay? We following? What's the last step I need to do then?
Divide by 4.
Divide by 4. Excellent. Uh-oh.
Yeah, that's an issue.
What's the problem? X can't equal 4. So you know what you do? It's really simple. Put an X through it. You showed me that it was equal to 4, but you also showed me it can equal 4. So I put an X through it saying, and that all that does is tell me, hey, 4 doesn't work as an answer here. So basically there's no solution to this question. Okay? But you don't have to tell me anything. If you do this, you're done. You've made it work. That's all you need to leave it as. We call this an extraneous root. We've talked about extraneous roots, meaning your graph doesn't touch a certain area. Okay? But in this case, x can equal 4. Done. Okay? We okay so far? Georgia, you following so far?
Yeah.
Oh, I forgot about these bad boys. Alright. So everything is great. Everything's hunky-dory. The problems. Now the only good thing about the problems is there's only one problem done the same way. They just ask them different questions. Okay? So these are complicated. I am not going to lie to you. Most of you will struggle with this a little bit. So I will do the best that I can to explain it. First of all, you need a chart to do these questions. Makes it a lot simpler. So we'll follow the first 2 examples through to make more sense to you. Andrea and Ferry are sharing a bag of popcorn at the movies. By himself, Ferry can eat the whole bag of popcorn in 20 minutes. Andrea takes 25 minutes to eat the whole bag of popcorn. If they both eat popcorn at their usual rates, how quickly will they eat the popcorn? Okay. Now, they're going to ask you. Brennan and Zane, they cut grass. Brennan cuts it in 24 minutes. Zane cuts it in 20 minutes. How long, if they were working together, would it take them to cut the grass? Those are the types of questions they're going to ask you. Okay? They don't seem that complicated, but they are a little bit. But, like I said, there is one process in which you do this. You do it every time. Once you nail it once, you'll nail it every time. Okay? So, they start by trying to organize this. Alright, so I've got Andrea, I've got Ferry, and I got both of them. And it says, the first thing is, how long does it take for them to eat the popcorn? So eat it all. What was Andrea? She ate it in how long?
25.
Sorry?
25.
25 minutes? And Ferry eats it in
20.
20 minutes. Okay. And I want to find out, my whole point to this is to find out how long it's going to take them to eat a bag of popcorn. So that's what I'm looking for. That's my X value. Okay, so far? So here's where it gets a little bit goofy, but it really makes sense after a while. What fraction of the popcorn do they eat in 1 minute? What fraction of the popcorn do they eat in 1 minute? Okay, so starting with Andrea, what fraction would they eat in a minute? If it takes them 25 minutes to eat the whole thing, you would eat how much in a minute? 1/25 of that, right? Okay, now, that sometimes is hard for me to comprehend. So here's what I'm going to say to you. Put your pens down for a second. I have this beautiful math clock right here. And it goes around. I got a second hand that goes around. How long does it take for the second hand to go around? It takes 60 seconds. Well, how far does it make it around in 1 second? 1/60th. Because it goes 1 out of the 60 seconds, right? So if this guy's eating, or she's eating a bag of popcorn in 25 minutes, she eats 1/25 of it in 1 minute. Agreed? Okay? How about Ferry? How long does he take to eat the popcorn? How much does he eat in 1 minute? 1/20th. And then combined, what would they eat? 1 over. We don't know how long it takes. But it's 1x of a minute, or of the amount, right?
You just average their speeds.
No, you cannot just average their speeds. Just follow along and keep up here.
Yeah.
Don't do it your way. Because we know you're going to have something that's going to complicate it. Right? Alright. Now, fraction of the popcorn now. So, let's say hypothetically, I want to know how much popcorn they ate in 7 minutes. So how much did Andrea eat in 7 minutes? 7 out of 25. How about Ferry? How much did he eat in 7 minutes? 7 out of 20. Right? But let's say that I let X represent the number of minutes of eating popcorn. Because I really didn't know how much. How do I show that as a fraction of the 25? So X is going to represent the number of minutes I'm selecting. I just selected 7, right? But it could have been 10, could have been 12, could have been 23. No, it couldn't. Had to be less than 20, right? So all I'm saying is I want to find out what fraction of the popcorn they eat in a certain number of minutes. Well, he's going to eat X out of 25. If it's 2 minutes, it's 2/25. 7 minutes is 7/25, right? This guy's going to eat X out of 20. That's how much they're going to eat out of 20 minutes. They're going to eat X amount out of 20. This is the part that confuses people. So, questions? Is everybody following? So X represents what again?
Amount of minutes.
The amount of minutes that we're selecting. Okay? Whether it's 2 minutes, how much popcorn did they eat? 10 minutes, how much popcorn did they eat? X minutes, how much popcorn did they eat? Well, they ate this proportion of their bag. X out of 25 and X out of 20. Okay, so far? Now combined. they're gonna eat one whole bag of popcorn. Okay? You two guys are gonna cut one whole yard of grass. So you would do X out of 25, X out of 24, X out of 20 to find out what 1 yard is. Okay? This is the hard part, setting it up. But they're going to show you, I think there's like 6 questions total, and they're gonna show you how to do it with a chart each time. In fact, I give you a chart on the test so you know to set it up with a chart. Okay? After this right here, now it's doing what you've been doing. Let's solve for X. So I'm focused on my last column here. Okay? So I have X over 25 plus X over 20 is equal to 1. And I want to solve for X. Okay? So the easiest way to solve for X is to always get rid of what first? The denominator. So I'm going to times everything by 25 and 20. Does that make sense? That's my 2 denominators. Okay? So I'm going to shorthand this. I don't mean to confuse you. That's going to be 20x right here, right? Added to what right there? 25x. And then 20 times 25, which is 500. Okay? Collect your like terms. 45x equals 500. X equals. If they are enjoying the movie and the popcorn together, how long is it going to take them to eat that popcorn? So you want to figure that out for me?
11 and 1
What is it?
9. 11 and 1 9.
11 and 9. Okay, give it to me in a decimal. That's what we can allow.
11 and 1 repeated.
11.111 minutes. Okay? Yes, Eli?
500, where did it come from?
Sorry, Eli. 20 times 25.
Equals 500.
20 times 25. And 20 times 25.
Okay, just making sure.
Yeah, that's okay. Good question. Just trying to do it without having to show you every little step.
Well, I get that. I just read it with the 500 because I thought 20 times 1 would be 20. But I see, I guess 20 is 25.
Okay? You good? Perfect. Anybody else? Okay. You girls will want to get to that, at least that far to do this next week. Okay? And if you struggle with it, I expect it. Right? But if you're doing it, do it a little bit together. See if you can work through it. Alright, the rest of you need to finish to the end of 6.3. And if you have to start on, or if you can't get to start on 6.4, great, for Monday. Okay? Alright, I'll save this and I'll answer any questions you have from yesterday.